something in between we can do when we check. Check that something adheres to uses an hash.
Let's try to do it this way. Hello. Okay. Okay, let me join the GVC as well.
I don't need it up there.
Oh, okay, you can. Okay, that's fine. Just use. Are you gonna present or do you want me to?
I can't present
Okay.
with the web browser.
I'll actually present. Share screen. Hey everyone. So we just want to do a quick get together after some discussion we had with some of the folks in the networking team. So the networking folks, Andre is going to actually be presenting some design about a protocol that we have been talking about, and we just want to actually share about this in our meeting as well. So what we are planning to do is we are planning to create a gRPC-based protocol for Istio components to disseminate configuration across the system. So the idea is components like Pilot and Mixer is going to actually implement this gRPC protocol to retrieve their configuration, and that will be the main, over time, that will be the main way for config dissemination in Istio. And Galley, the new component that we're working on, will actually be the main touch point to the Kubernetes CRD system. So Jason has been working on it. We just want to give a quick, update on the effort that the document has been, I believe, shared before.
Yeah. Okay. Can you scroll down to highlight the problems we're looking at? So the biggest problem one of the biggest problems we're trying to solve is we have very tight coupling between the components and the environment they run in, and we want that to be more loosely coupled, which is why in the extreme form of this proposal, we have gRPC, proper network APIs between components and between the components and the environment. So that's the main problem we're trying to solve. So the biggest case we hit now is with the API server dependency that Pilot and Mixer have. So we want to loosen that. So we can start Mixer or Pilot, point it at possibly even a simple file-based implementation of this config distribution server, and be done with it. You don't have to start at CDU. There's aspects of the granularity of config. So eventually when we get to canarying and rolling out things more incrementally, we'll have be able to have mechanisms to do that. Be able to ACK and NACK config updates, so we know when a component has accepted it. And consolidate config across CRDs, config maps, and binary flags. Right now, things have just kind of been ad hoc. And it's hard to reason about where all the config is coming from. Some things are static, some things are dynamic. Having to restart components to get some of the config updated, but other aspects of config are dynamically reloaded. It's just not consistent and hard to reason about. And we want to make the client code more efficient so that it just consumes protobufs directly rather than having many intermediate forms that aren't consistent across components and even within the component itself. So we don't have to convert from JSON to YAML to proto every single time we ingest config. We just have one ingestion step. So the non-goals that we for the overall for Istio, we don't want to remove the API server. That's still the user-facing authoring model that we want to support. So there will be first-class support for that within Galley, but there will be options if somebody wants to implement alternate schemes that would be for local testing, for test framework, for a test framework, or for local development, or if a partner wanted to integrate in their environment, it should in theory be a bit easier. So possible, but we're still committed to the API server for our authoring model. So here's the picture, which captures the overall model. So this is so starting from the left. I think you can see the numbers here. There's the Galley component, which has a dotted line around it, and that has a subscription management component or subscription management aspect to it that has that can stream out config to components, and then there are adapters that sit in front of that. Logically, it's all part of Galley. TBD whether those are in process or out of process. The basic idea is that we decouple the distribution of config in Galley from the config ingestion from the environment. So in this case, Galley would watch the API server, watching CRDs and other configuration environmental data, such as services and endpoints. It would ingest that to a Kubernetes adapter and update internal subscription state and push that out to components that have subscribed to those particular types. So a component, take Pilot, for example, would subscribe to its networking APIs, virtual services, destination rules, along with mesh config, and possibly one variant of this is maybe the service entry, which has service endpoint mappings. It just gets subscribe for those types from Galley, and then Galley would push them to Pilot as it sees updates in the environment.
So before you mentioned the ability to ingest from files instead of a config system,
yeah.
You expect that happening? Galley would do that, or the components can do that?
It would not be in the component proper. It would be. So you have a layered approach. So if you're writing, so Pilot would eventually have an API to say, yeah, I'm going to subscribe to changes. And I don't necessarily care where that's coming from.
Yeah.
I can point it at an out-of-process adapter that's co-located with Pilot. I can point it at a remote process that is maybe still dedicated for a particular resource type. I can point it at Galley proper that is then ingesting from CRDs, or I could point it at a test, point it at Galley, but Galley is ingesting from files, or I can point it at, it doesn't, the component shouldn't care.
Well, the point is that, what you're suggesting is the component just has the gRPC protocol, period. Any file-based stuff is done outside of that.
It would be outside of the component proper, right?
Okay.
But the file adapter, there's two variants of that. You could have a very simple server, like a test framework that's dedicated for that purpose. Maybe it has some setters in its memory, and that would be ideal. You don't need to go through files in that case.
So
and that doesn't have to be Galley per se.
yeah, just from a isolation testing standpoint, since we're going to have a common library that the components are using, it might be worth putting file support there. So now I can run Mixer completely in isolation. I don't need these satellite things that are running, so I can reconfig from.
Right. So there's, as this is built, I think we want to take these reusable chunks. Our blinds in our room are automatically opening and closing, which is distracting. Yeah, take these reusable chunks and push them away in a common directory. So a server implementation, I think, is a good candidate for that. Client, there's some debate about how much we can generalize the client, because clients have some different use cases for how they would ingest config. So the Mixer might want to adjust it more as a snapshot, whereas Pilot might want to do an incremental update. So it's TBD how much we abstract and you just take a library and it does everything for you.
Okay, I mean, the critical point I think is the use case. If you're envisioning the file-based model to be mainly for like ease of development / testing, then it should be very easy to say, look, in this library, you can actually have a one-liner that allows you to create the service within the same binary that just happens to read the files and then feeds to the client side. Okay, I mean, from a testing development perspective, that's a very trivial thing to do. We can do that. It's part of the framework. Like Galley can use it. Other components can use it. Everybody can use it, right? And that works. But if you're thinking, look, this would be an extensibility point and should be used in production, that I think it really needs to be a component level thing, right?
Well, interesting. No, so in production, data goes through Galley.
Yeah.
Now, in production, it would be reasonable to have Galley be able to read from a file system for the VM case, right? Just stick the files there, the thing starts, and it just works. Have components read from files, that's a development time convenience kind of thing, right? So in today's world, I can point Mixer to a file system, and it will get the configs from there, and I don't need to start up any other dependencies. I think that's a valuable.
So I think functionally we can do this, right? Based on if you have a server implementation that you can just point to a file system like a directory, then okay, functionally we can do all of it, right? But if you're gonna want to go further than that, say no, that's going to be actually expensive in an actual real development scenario for the components. Then it's a kind of per case by case basis.
So that's one of the reasons I put a dotted line around this was, if you have these reusable chunks of common library code, how much Galley specific code is there? There might not be all that much. Maybe all the subscription code is common, and that can be used for this purpose and memory purpose. Or you keep it under Galley directory and you use that as a package. So I think there's probably more of a principled doc saying here's a strategy we want to take, and not the exact implementation we're going to end up at. The key is if we have the protocol defined and that we have a good reference implementation with some reusable code for the tricky bits, we can get pretty far, and then we'll understand longer term what we end up supporting, because we could have every single variant, right? Plugins all the way down. Probably doesn't make sense. Not all of those will be used. It's not worth maintaining all. So stuff we'll find a happy medium. So it's using a bidirectional streaming API, a gRPC bidirectional streaming to push configuration updates to components, client server protocol, which is based on the XDS gRPC protocol, but I think we'd probably give that a different name. Pilot proposal, which is going to be covered in an hour. They're using MCA, which is Mesh Configuration API, but I think we're all open to different naming suggestions. And that carries an existing APIs defined as two APIs. So networking, authentication, the mesh config itself, which is a config map, all of that would be delivered to that aggregate API. Delivered as protobufs. One key here is we currently don't deliver metadata in the resources. That is kind of duct taped together with CRDs and it's not consistent across components, we need to address that. So the metadata needs to be encoded in the resource itself, either as a new type or extending the.
Or does it?
Well, if you have a name for a resource, so if I give you, here's an instance. Instance doesn't have a name in it. It's in metadata.
Yeah.
And the binding of a rule to an instance uses that name.
Yeah.
And similar things happen in the networking APIs. So if with XCS proper, with Envoy resources, the resources have names. So if you have a listener that, or a route that references a listener, their names in the resources. So there's various ways of doing that. We can just extend the fields, and there's no common metadata, but at least the names it's a self-describing. Or you can introduce a metadata object and embed that in the resource, but it's going to be in a different location, different field number for every resource. You have an envelope, so you have an instance envelope which has metadata as field number 1, and then the current payload, which is the, or you have just a generic Istio object that has metadata and then an any that carries the.
So any is a bit problematic in the sense that actually what you want is one of semantics. I'm not suggesting that we should use one of, but any implies like double decoding, right?
Partial. Well, so if you decode it, I understand if you decode a proto that has an any, you just decode up until the point that you hit the any, and it skips over it. So you're not doubly decoding. You're calling a decode function twice, but
so if you imagine
it will allocate twice too, I think, and that's one of the.
But this is not a performance.
But it's gonna be right. So it's, I think, like we're gonna be holding a lot of objects in there.
Yeah. So the way I imagine this going is you have the wrapper object with an any. It hits the client library. Client library decodes the inner part, passes that down, and then the metadata is passed kind of on the side as metadata. So the code that the code in the component is dealing with the proto of its own business.
But it's still, so like when I'm writing code and when I am trying to make these things work together, like especially like if I'm processing the configuration, I have to deal with two objects, right? I'm wondering if we can say, look, all of our objects, like the spec parts essentially, are have name and namespace, or just name with fully qualified name, right? So
we really want inheritance. That's
it's a bit tricky with Protos to make this work to address all the cases
and with Go.
So that's TBD. I think some of it will depend on.
But to our discussion the other day, though, with Go duck typing kind of stuff, this right, it could just be by fiat and via linting. All protos shall have these two fields,
right? So
and they'll implement the get function, get name, and get namespace functions.
So the simplest thing is to stop. It's debatable whether we need the namespace at that level, unless it's domain specific. So some networking APIs assume namespace. They also assume domain to do the fully qualified expansion, or maybe that is hoisted out of the component, and that resolution is done by.
So I think at the minimum we can actually have a name field and say, by the way, this can be fully qualified, right? And then you don't have to use like scope-based resolution mechanisms. Everything could be fully resolved, right? So the only time when it matters is scope-based restrictions,
which is something that one of the value adds of Galley is we can have that enhanced validation.
Yeah.
That goes beyond just tackling the resource in the namespace. We can say, here's a network name that you own. It's fully qualified, or maybe has wildcards in it. But you own that. Do you own? You have the ability to write policy against that.
And by the time it hits the component, it's fully resolved. There's no lookups and hierarchies to walk through and that kind of stuff. Anyways. So in fact, that's kind of the only way we can do it and be platform neutral. Right? It's right now we've got Kubernetes baked into many places. Once we start pulling that out, our components need to be, I think, the Kubernetes-ness needs to be taken care of elsewhere.
Okay. So
Okay, so
that's-
what it boils down to is that every chunk of config has a unique identifier.
it needs to be self-describing. I mean, that's, right now we have extra data that's passed. So in Pilot, what the runtime uses is the proto plus this
Stuff,
metadata.
yeah.
And Mixture has something similar, and they're using slightly different bits. So all of that extra stuff needs to be encoded in the resource.
Labels as well.
There's labels, annotations. I didn't see a use of them in Pilot, and
Yeah, Mixer doesn't use them.
Mixture uses them. So
Yeah, so let's not pass it
we
until we
can
need
we
it.
can take that out and just say we're not going to have any common metadata. It's all a single resource, and we can keep the existing resources. And we done click. That's probably the most straightforward thing. And then the nice.
Well, it sounds like to me the best approach at this point is to mandate that every config proto has a metadata field that points to a message that currently only has name.
So that simplifies some of the implementation. We'll still need Galley it wouldn't be able to generically reason about config. There's still some special casing that we need to have, which is maybe okay because we're doing resource-specific ACLing, domain-specific ACLing anyway.
Let's keep in mind the end goal here is to have to get service configs and have Galley figure out how to distribute this to components. So Galley is going to have intimate knowledge of the components config
Right.
format
So-
by definition.
So that's
So it's okay.
yeah. So it's not a huge deal. We'll need some mapping file, and to be how dynamic that is to map, say, a CRD onto a proto. At least in the near term, where we have a one-to-one mapping between the two.
Yeah.
Logically, and know how we locate. We translate names.
yeah, so I think you can't avoid code-based translation for most of those things. Like at the beginning, you can. I think maybe the right thing to do here is to actually. I'm just spitballing here. Like create ghost structs for our current config experience on Kubernetes. This allows you to create client libraries as well. And for each one of those configs, have handwritten code that transforms into proto, right? So, I mean, the handwritten part might be automated to some extent, but if we expect there to be a deviation from the editing experience to the component config, like the namespace resolution, right? That's one of the examples. Then it might be better to just say, okay, we are going to bite this code. Like, we're just going to eat this code now, and create these mappers. Ideally, should be very straightforward.
Yeah, I think the key there is whereas the API server and CRDs in particular are very extensible by nature. That that's not the system that we're designing. So the requirement of having common metadata that is completely dynamically extensible is not a key consideration for us. It's very specific to the SDL components that we have. So there is domain-specific knowledge that needs to be included. So some of that's what we'll see in the networking discussions. What they're comfortable with, they need to make some changes to their some extensions to their APIs.
Okay.
And then the nice thing there is if you have unique types, it maps well to the XDS protocol. So a component can say, I would like to make I'm going to watch virtual services, I'm going to watch destination role, and that what they're watching, what they provide as the identifier is the fully qualified protobuf type. You have a common protobuf that gets really, it doesn't map well onto that. Because when you say, I want to watch Istio config, and I need some other way to tell you, I don't want all Istio config, I just want networking specific. So if they're the proper types, that works well. The Galley would implement this MCA server. And then we have some pluggable nature to it, where we could have CRDs, but also files, or if somebody wanted to go and add their own thing, it's something we can consider. It's architecturally sound anyway. And they could be in process or out of process. And TBD, I figure we start in process, but or potentially it's something that it's a separate component or separate package that can be moved out if that proves valuable. And we have allowances for testing, which we already discussed. So I have a reference to the platform independent extensible pilot, which is kind of the same discussion but very pilot specific and what this world looks like for them. In that case, it's basically pilot is a simple component. It has a lot of different arrows coming into it from different config ingestion servers. This is an overview of the protocol for those not familiar with the Exodus style scheme. I don't know if I need to go into that or not, but it's there as a summary. On the lines of the protocol, it's sufficient for current purposes. It's a watch-based scheme where the client can additionally ACK or NACK config that is received and start new watches within the same gRPC stream. The server delivers a state of the world, which is sufficient but not efficient at scale. There's a proposal to add incremental support for updating and deleting resources, which is exactly what we would propose. And so once we have that, it does most of what we need. If there is any cross-resource or cross-type dependencies, there are some ways we could handle that. We can just ignore it and let the component resolve that at runtime, or we could bundle those dependent types into a single kind of meta resource, meta type. So mixture might have a mixture config, a mixture rule, and a mixture rule has the embedded. It can be a one of them there, or an any. It can be any one of those types, and then we can deliver them as an atomic group.
Yeah. So basically, you're saying there's a difference between the actual config types is independent from the transport types. I can package those in different ways.
We could, yeah, we can explore that. I mean,
Yeah.
the first pass is there's a one-to-one mapping from a CRD to the prototype that we deliver to the component, and we have the same problems that we have today. In whether we care about them, we can fix it in the component itself. So make sure it could, like it does today, kind of not apply configuration that's not consistent.
Correct.
Or we could change the model later and just bundle all those in a new type.
Okay.
And Galley would be responsible for aggregating.
So, assuming that you also kind of ratify this in the networking group, what's the lead time to having it available, do you think?
As available as an option.
As I implement, like just for the protocol part?
I think it's reasonable to assume we would have this as something that somebody try in a month, but it's not production ready. Certainly, there's auth and auth Z to sort out to get that consistent in the configuration around that. Assuming that there's component dependencies, so this obviously has to be adopted in the networking group to be one of the variants for pilot, and same thing for mixture. We have to be sensitive about how we implement that, so we're not too disruptive, particularly for one another. So I think in pilot case, you can make the change so that it's not risky. It's just one of many options, and if you don't enable that option, you must flag disabled. But it is available. We can start testing with it. And I believe it's probably mixture has its own storage. It's pretty well isolated the config ingestion store. So as long as we do, a lot of the work there will be getting the optional flags plumbed through the Helm or whatever, so people can try it safely. But if they don't turn on that option, they still have the current scheme. And then longer term, we can start phasing things in and phasing things out.
Okay.
And then also scale, and that's something I'll probably come later. We'll have something that's functionally correct, but maybe starting too many go routines per watch. But then understand longer term how many pilots, how many mixtures we're going to have. This could, in theory, be used by the pilot agent, in which case then scaling requirements go up significantly because it's one per proxy. And they're doing it definitely with benchmark.
Jason, I noticed you're also on the proposal for the Istio networking meeting on what seems like a way to separate out like pilot adapters almost that Andre's going to present at the networking meeting. Do you have a semblance on whether this would go in before that, or are they mutually exclusive?
So that's about these adapters are really about the service registry, service registry aspect of things. I think it's kind of orthogonal to this. Right?
I think there is thoughts about actually using this protocol to communicate. Like, there's the communication protocol for those adapters as well.
Oh, okay. Same protocol.
It's a longer term thing. So if we said like 2 years, what would a reasonable architecture look like? This MCA thing it can kind of be all the way down. So you could have an adapter in front of Galley, between Kubernetes and Galley, and then from Galley to a component, and then a component could fan out with the same protocol.
Yeah.
You have a whole hierarchy of these. Near term, it won't look like that. Near term, Pilot already has in-process adapters. This would be another kind of in-process adapter, in-process config store. But over time, I think there's desire to consolidate those and push them out, certainly push them out of Pilot.
But do you think we could just use the exact same code then in Pilot? So Pilot would read from Galley and read from whatever service registry thing using the same code?
TBD. So
seems like a good objective.
It is. I think it's a good aspiration. Where there might be a difference is due to the scale and the nature of how quickly config can change. Pilot might want more direct access to the protocol. So what that is, if it wants to see here's a new resource, or resource is deleted, and it doesn't want something else to consolidate that into a full snapshot. Because if you give it a full snapshot, we need to undo that. And say, here's my previous snapshot, I'm going to diff it and figure out the ads. And that's not efficient. Whereas maybe Mixer wants the full snapshot. Here's your config, use it. And if you didn't have to build up your state, you wouldn't mind. So I think it's premature to say we know exactly what that common client code would look like. There's a minimal wrapper I think we can do. So if you had a callback that said, here's a new config, here's things that are removed, or here's the full state of the world. It's a little bit of code, plus all the code that is generated by the Proto-C compiler. So it's not, we do get, just inherently with gRPC, you get a client library.
Yeah.
Did that answer your question, Chris?
Yeah, I guess also similar to the auth and auth-C stuff. How do we do like validation? Like, assuming you can kind of push configuration over gRPC, what do you do for like external adapters or ones that aren't like Istio native per se? Like, for example, like, do we have like a list of, hey, these are things that it's more of a question to extensibility of Istio and creating your own Mixer or Pilot adapter. How do you validate that this is a good adapter that we can work with? Or do you just open it up for anything that registers with this endpoint will work?
I don't think the nature of the system will be that extensible.
Well, for adapters it is.
Yeah, so putting aside Mixer adapters, the other aspects of config, for CRD validation, a lot of that we could have Kubernetes do, so we can auto-generate the schema and provide that to the API server, and that part can be dynamic, but we still need to use that. Galley needs to know, here's a new type,
Yeah.
I need to translate that to a protobuf. So we could eventually make that dynamic. You know, if we had common metadata and we had a mapping file.
That's the thing. I think so. From a configuration for adapters, ideally we're going to move away from imperative validation and go to declarative validation. So on your proto for your config, you declare basic validation. So this field cannot be null. This string must match this regex, and that kind of stuff. Mixer can then validate that schema, and then you get some base level quality assurance before the config is delivered to the adapter. Yeah.
In terms of where that's validated, so the general validation scheme, we can validate what the users have authored. Components can also validate. And if they see something that's not correct, they can knack that config update. And we can try to propagate that back to the user via a status.
Yeah, I think that's an area where we need to be a bit more explicit about the behavior, because NAC is like as things stand. I know this is based on XDS, right? So it's not a comment about that, but essentially a single NAC over a stream of changes is a bit like too coarse, right? So it's very hard to.
That's one of those, yeah. So it will work. I'm gonna say we know that the component can say there's bad config, and I can provide an error message that indicates possibly what the name of that piece of really was. I think one part of the incremental update, config update is you can knack the individual. You're not knacking individual resources, but the knack can indicate which of those resources is bad. And if it doesn't, that's something we can take to the community and work for enhancement.
Yeah, unfortunately, all that stuff happens after the config's already been ingested into the system, and it's already the source of truth. So you now have a corrupt system.
So you can't restart, actually. That's the main problem.
Yeah, so it's there. It's been saved, and we're just observing that fact. And
well, that's fair, because you can do the same thing if you create a pod. You can create a perfectly valid pod that points to an image that doesn't exist.
Correct. So I think that's an example to not emulate if we can. As much as possible, don't do that.
As much as possible, but in the case of Pilot, unless we're going to have a synchronous blocking chain all the way under the proxy, it's unavoidable.
Yeah.
So you move as much forward as you can declaratively. Have a declarative scheme to validate this config.
Correct.
You should do it. If Galley can have additional cross-reference checks to make sure it doesn't deliver inconsistent state to a component, it should. But there's always an escape hatch. If a component gets bad config, it can at least indicate.
Yes.
You
certainly don't want silent failures.
So it's not silent, and then you have to propagate that back up. Your source of truth is bad, and there's not much. We don't want to auto fix that for the user.
Not yet.
I mean, okay. So if this is the problem that I have in general with the system, right? So okay, so we can get a knack back, but what does it mean essentially? Does it mean the component actually retains its own
the
previous state?
Yes.
Okay. Then if the component starts back again, you cannot rebuild that state. Okay.
If it starts back.
So okay,
the source of truth has been upgraded.
Yeah.
The component saying, I don't know what to do with the source of truth. It's corrupt, so I'm going to keep my current state. And then when this thing reboots, it's going to say, what's the source of truth? Oh, it's this new state. Oh, I can't use it. Fail. So, right. Once you start pushing bad config into your system, you are no longer in a usable state.
Right. So the sooner we can detect that, but it's still
and realize that
can completely avoid it.
But having this as it just seems terrible that as a operational aspect of things, it's a flag on a resource that you set 10 minutes ago that says, oh, it's bad. Everything keeps working until it needs to restart, at which point, then your whole cluster starts going down the toilet.
So some of that, so the example is There's not one solution to that, but say, the example you gave, Galley gets config to Mixer says, no, that's, there's an error here. Here's the last version that I am using. And then Mixer crashes and restarts again. So it has no config to use. And
Correct.
Galley should not deliver that bad config again. So I have to know, like, okay, here's a previous version that I could deliver to you, or I'm just not going to give you anything.
Without actually having additional storage, you can't do that in the general case. Okay?
No, so what should happen eventually is that Galley would see there's bad config. It might indicate that to the user. The user could go and say, okay, I'm going to undo that because I see that, I'm pulling status of my config and I see that it was NAC and it says that such field is not present. That Mixer caught. Okay, well, I'm going to go and I'll undo it. And then there will be a gap where Mixer, if it crashed and then restarted and requested config, it's not going to get anything.
Yes.
You can automate that further, so you have a rollout mechanism which would monitor the status and maybe canaries at first and see that the Mixer, when Mixer validated it, okay, it's good, I have some confidence, I'm going to start rolling it out at any time. If I hit an error, that
So,
layer above.
I think
maybe
it's
think
creating a bifurcated status path, right? So you actually have, you need two statuses now. One of them is the ACNAC path. The other one is you also need another path, at the very least, to see whether the runtime state of the system is porked or not, right? So that you probably want to actually show on the as a status as well, right? So we are really creating these two models, and we are saying, oh, the NAC is for like the configuration part. If it's not, if NAC is about configuration only and not deals with the runtime state, then we should almost never get a NAC. Yeah, because we should be able to validate this, right? If you should almost never get a NAC, okay, what's the value of NAC? I mean, what's the
Well, but that's the thing. This is to cope with the fact that declarative validation has limits. So there's a little more validation potentially, and then you'll get a NAC from that.
And we know
But,
when it's applied. So if there's a hiccup in a component.
So an alternate model could be, right? So why don't you give me a bunch of lambdas for each one of these types, right? And I can run that code in Galley, right? But it's a single lambda has no.
Where do they come from?
We write in a common shared library, right? So.
But that's the thing. So that just doesn't work with adapters. It's fine for Mixer. It's fine for Pilot, not for open-ended set of adapters. Now, if we want to support something like
but then it's
JavaScript or something, then potentially we could run this in Mixer.
But then it should be categorized as a runtime failure. So it becomes a limping system, not a I nacked all of the updates and I'm just going to retain my original state, right? So if we don't have that limping model, then you will run into this, I started again now and I cannot rebuild my previous version of the system. So you have to be always on the latest plan, even though that plan sucks, but you should be able to limp through, right? I don't
know. So if you a combination of a canary stage rollout and if we assume that the store that Galley gets its config from supports versioning, which CRDs are supporting versioning, then Galley could be in charge of this thing. Look, I delivered this config to this component and it keeps crashing. Let me.
But I believe that versioning is not meant to be a watermark versioning where you say, up to this point, this CRD is not now valid, right?
Yeah.
And then it's more of a historic thing. My understanding, right? Okay. So, and even then, Galley crashes and comes back up.
Yeah. So
then you actually lost that ephemeral state thing. Oh, this is this is the last
this
thing.
assumes you're actually writing CRDs. Galley has some persistent store someplace to store its state.
It might be reflected back in a certain.
Because the same thing happens. It's not just about crashing. It's also about multi-tenant Mixer or HA Mixer. What am I saying? HA Galley. You have multiple instances of it. They need which version did one deliver to Mixer versus the other one? So if you have a small amount of persistence stored back into the config system, it's a slippery slope.
Yeah.
But anyway, even without that, if you just have the canary and the stage rollout model, you should go pretty far with that.
Okay, I mean, we can.
But okay, the reality is, in all the adapters we have today, all of the validation that we perform in the validate functions can all be replaced by declarative checks.
Which is fine, but I think that I don't think that's the main point, right? So you are designing a system and you are actually putting an ACNAC boundary. Let's assume that we don't put that boundary. I just push everything and that's it. Okay. The problem is actually at the component level now. Like, you still want to do as much validation as possible upfront to avoid pushing like negative things, but you avoid a step function in between where, like, certain combinations creates like hard to reason about states, right?
Yeah.
So the state is very easy to reason about. It's just it's a broken state, right? But it's a consistent model. Is all I am trying to get to, right? So ACNAC doesn't actually buy us much in trying to create a more resilient, more easy to reason about system.
Because of the restart case.
Yes. Okay. Yeah, I guess we have to end now. We have some other meetings coming up. Thank you, folks, and feel free to comment on the document or on the agenda. And I'm gonna stop sharing. Oops, actually there was somebody.
Everybody already got that.
Okay, so actually.